Okay, so more conics practice. This is from the 2009 exam. Find the equation of the parabola with focus 2, 7 and directrix x equals 11. So I went ahead and sketched those, or I had the computer do it. Here's x equals 11. Here's the focus 2, 7. So right away, we know the vertex is going to be halfway in between those somewhere. We'll get that in just a second explicitly. And we know it's going to be a right opening parabola. And that's really nice for just sort of checking our work. Okay, so the home base, crucial, that's the vertex. Oops. For a parabola, remember. It's the center for a hyperbola or an ellipse, but it's the vertex here, so we want to get that first. And that's easy because it's the point that's halfway between the focus and the directrix on the line of symmetry. So I went ahead and drew the line of symmetry because that's going to be perpendicular to the directrix. That's an x equals, so it's going to be a y equals, and it's just going to be going through the focus. So it's y equals 7. Okay, so it's on the line, the axis of symmetry. Y equals 7. Okay, so that's the y-coordinate of it right there. And it's halfway between the focus and the directrix. And so we just have to average 2 and 11. So it's just going to be 2 plus 11 over 2. That's going to be the x-coordinate. And so that's 13 halves. If you want decimal, 6.5. 5. Okay. So we've already got a lot of our form. We know it's left-right, so it's going to be a y minus k squared equals 4p x minus h. We know the center. Let me just summarize what we did before here. Center. Sorry, this is the vertex. I'm rushing. I'm sorry. I just want to get these out so that you can watch them. 13 halves and 7, because we know it was y equals 7, x equals 13 halves. Okay. That's the vertex, so that's what goes in here. That's our shift. That's our home base. Put in the shift. Okay, now we just need p, and we'll be done. Well, p, remember, is just the distance from, it's the directions from your home base to the interesting stuff. Okay. I think I already put that in the other video pretty much. The directions from the vertex to the focus in particular. That's the more particular version of it. And so that's going to be negative, because it's a leftward opening parabola. And so p is going to be negative the distance from this guy, 6.5 to 2, that's just 4.5, or if we like fractions, 9 halves. And so 4p, which actually appears in the equation, is actually minus 18. And so we just put that in, and we're done. Okay, and I actually had it pre-graphed, so let's delete all this filler. Okay, and there we are. There's a bigger graph. There's the focus, there's the vertex, there's the directrix, and there's the graph of the thing. Looking pretty good. Looking reasonably like that might be the right parabola. Okay. Now, next one. Find the equation of the hyperbola with vertices at 0, 0, and 12, 0, and asymptotes. Ooh, those look complicated. Well, remember, these are just straight lines. These are just straight line equations. And notice how similar they are. They just have a plus or minus, basically, in front of the 3y, which makes sense because we're used to seeing plus or minuses for the two opposite slope lines that form the asymptotes of a hyperbola. Well, the first thing to do, of course, is the home base. That's the center for this guy, and that's halfway in between the vertices. And that's a pretty easy proposition to do. That's 6, 0. Okay, so that's good. We already know that. And now we need to find A and B. Okay. They don't give us the foci, and they don't ask for the foci, so it's unlikely that C is really going to come in. It's really about A and B. Well, A is always the distance from the center to vertex, and we already have that. That's just from 6, 0 to either 0, 0 or 12, 0. So that's 6. Okay. Now B is a little trickier because they give us the asymptotes, and we could kind of slot that into memorized formulas. The way I think I would do it is I would draw the box. Okay. Well, let's see. What does the box look like? The box looks like, in other words, we start from the vertices and go up and down to hit the asymptotes. And then how far you go up or down, but let's just say up, is B. Remember, because that's the meaning of that's how the box relates to A and B. The box is just you go A left or right and B up or down from the center. And so if you want to know B and you know the asymptotes and you know the vertices, that's not going to be too bad. Okay, so we start at, let's say, 12, 0. And what does it mean to go up to the asymptote? Oh, I just need to figure out if I'm at x equals 12 and I go up to one of these asymptotes. Well, maybe this is down. Who knows? We'll see. We just need to find out the y-coordinate. Now, we'd have to be a little careful about this. Usually what we want to find out is how far we changed in y. Well, y is starting at 0. So we can just go ahead and find the y-coordinates. Well, that's pretty easy. We're just plugging in. So this, again, this isn't the only way to do this, but this is certainly the way I would do it. So you plug in 12 for x, 48, minus 3y, minus 24 equals 0. We may end up getting a negative here, which just means we accidentally went down to the bottom asymptote. That's fine. It'll still give us b. Just take the absolute value. Okay, so to solve for 3y, 3y equals 48 minus 24 is 24, and so y equals 8. Okay, so in fact we ended up going up. That is equal to b. Okay, I'll show you the picture in a minute. I should have done a prep picture, but oh well. Okay, so b is equal to 8, and so now we're ready to rock and roll. Actually, let me show you the picture here. So let's see. And I already have the hyperbola plotted on the picture, but that's not a big deal. Wow, I put a lot of space in. Okay, so here's our two vertices. And so again, the way I would really do this on paper is I would go ahead and start sketching. The vertices are 0, 0, and 12, 0. Here's the center, 6, 0. And then what I want to do, geometrically what I was doing with the algebra was starting at 12, 0 and just going up and trying to find the box is going to be right here. I didn't draw it in. I probably should have. The box is going to be here, all this stuff, vertex up to and down to asymptotes, vertex up to and down to asymptotes. Now, you know I sketched in the asymptotes carefully, or I had the computer do it. You don't need to do that. You just need to know that they're there, and then this algebraic calculation tells us if we plug in x equals 12 for the vertex, and we want to know what the corresponding y is on the asymptote, we just plug that into the asymptote equation. And this distance from the vertex up to the top of the box, that's b. Okay, and so now we can plug in our equation. So it's x minus 6 quantity squared, because that's the shift, divided by, and then it was 6 for a squared. It's a left-right opener. I should have said that pretty early on. We already know from the very start, we knew that the vertices were left-right from each other. So it's a left-right opening parabola. The major axis is a horizontal axis, and that's going to be where this guy, the x, gets a plus. So it's going to be this guy minus, and then y was not shifted because these guys were 0, divided by, and then here was the tricky one, getting that 8 squared equals 1. Okay. So this is a bit of a tricky one because they give you the asymptotes like that. You could definitely do it in different ways, but I just love the box. And I love things that are sort of more geometric than other ways. And I think this is good. You're basically kind of going backwards. Usually we use the box to get the asymptotes. Here, once you get the center, the vertices, and you have the asymptotes, you can actually draw the box and get b from that. Okay. One last one for this bank. I think that's all the ones I'll do for this, and I'll do some other different kinds of problems later. Identify this big expression, this big equation as a parabola, circle, ellipse, or hyperbola, and find the foci. Well, if you're pressed for time and you want to get a point or two out of 5, you just look. 9 plus 4, these are both plus and they're unequal. There's only really two possibilities. It's almost certainly an ellipse because they're unequal and they're both plus. It might end up, when you complete the square, it might end up being impossible. You might get something like 9x squared plus 4y squared, you know, something like this. 9x squared plus 4y squared is negative. A sum of squares is being negative. That would not be good. It'd be empty. But most likely it's an ellipse. And if you just justify that saying unequal and positive, I'd give you a point at least. But let's actually go ahead and complete the square. So let's copy this down. Okay. And so we've got to put the x stuff together in an x house. X squared minus 36x. Oh, and I got to factor out the 9. Okay, so really important. Put the x stuff together, and if you have a factor in front, that factors out of both things. That's really important because this stuff has got to be together without any interference from this guy, so that's why we're putting it outside the door. It's like putting the cat out at night. Then plus 4y squared plus 2y. Okay, so there's these guys, and I factored out a 4 out of that guy to make a little y house. And then the odd, I'm going to put this stuff eventually on the other side, so I might as well do it now. Now, the key step of completing the square, that's x minus 2 quantity squared, which almost matches, but it's giving me an extra 4 that I don't want from the 2 squared. I subtracted off. Remember, this is always a minus. That's always gets subtracted. Even if this is a minus, that squares to a plus, and you get to kill it with a minus. Plus 4. Remember, the way I do this with the parentheses here, you get the parentheses to make the x house, and then the parentheses for the square. And subconsciously, you tend not to want to do that nested parentheses. They are crucial. Crucial, crucial, crucial. So please convince yourself that they're necessary. Now, the y squared plus 2y is just y plus 1 squared minus the 1, because I just added in a 1 squared that I didn't want. The minus 4 is just sitting there. Now I just redistribute. That's where those extra parentheses, the outer parentheses, go away. Okay, so it's going to be minus 36, and then the plus 4y plus 1 squared minus 4 equals minus 4, and then just collect the constants. And okay, so adding the 4 is going to actually kill that guy. These guys cancel across, and then just get a 36. Oh, surprise, surprise. It's contrived to be nice numbers. Now I'll just divide by 36 to put it in standard form. Quantity x minus 2 squared over 4 plus the quantity y plus 1 squared over 9 equals 1. And I'm even going to go back in there and rewrite that as a 3 squared. And rewrite that as a 2 squared. Aha. So now, the point was to, well, first of all, we're now absolutely certain that it's an ellipse, because we get it in standard form where these are unequal. This is plus and plus, and so it's a shifted ellipse. And now we just need to get the a, b, and c. Well, a is, of course, the bigger one of these two numbers down here. A equals 3. B is the smaller one. And the foci are going to be determined by c. Well, that's the square root of 9 minus 4. So that's root 5. Oh, thank goodness, a square root coming in finally. Okay, now, where are the foci? C tells me how to get to the foci relative to the center. Ah, where was the center? The center, C, is, well, that's what the shift is about. That's 2 comma minus 1. And so to get to, oh, and then which way is the major axis? Ooh, it's an up and down, because that's where the big number is. Okay, that's vertical. And so the foci, you're going to go vertically from 2 comma minus 1. You're going to go plus or minus root 5. We're not going to change the x-coordinate. And you're going to get minus 1 plus or minus root 5. And I'll show you a picture in just a second. This, by now, I would have probably started drawing a picture by hand. Once I got this, I probably would have just, you know, put down a couple axes real quick and just plotted the point 2 comma minus 1 as my home base. That's this guy. And then and put a vertical axis through that dotted line. You don't need to even draw the whole ellipse, but just to get some sense of what's going on. And then let's look at the picture. Complete with ellipse, although this is not what you would need for this kind of problem. So there's the center. I probably should have plotted the center, but here it is, 2 comma minus 1. And it's a vertical ellipse, and it goes 3 units in up and down. It goes 2 units left and right, and it's root 5, which is about 2.2, 2.25, going up and down, and that's the foci coordinates right there. Okay, that's enough for conics.